then all the solutions that you are getting, all those are equilibrium points, whether they are isolated or continuum, that we'll have to characterize later. But x dot, the solution of x dot equals to 0, from which we get to know the equilibrium points, it doesn't characterize whether immediately they are isolated or not. That we will have to analyze later. Now, your question, that is whether, that is how much is the strength of that equilibrium point, that is the dependence upon the initial condition. Now, please look into this picture. That is here, this is a theta dot versus theta zone. This is one equilibrium point 0, 0. This is another one plus pi 0. This is another one minus pi 0. Now, if your initial condition is within this region, then whatever initial condition you take, it is guaranteed that it will come back to this equilibrium point. Okay? But now, if you take an initial condition somewhat here, or even suppose somewhat here means, can you see theta dot is increasing? Then what will happen? It will have a tendency to go to the other equilibrium point plus pi 0. But the nature is plus pi comma 0, that is an unstable. So it cannot lie there. So then the situation will be, that is after that is if the initial condition is somewhat inclined towards this region, that means way ahead from this, then it will have a tendency to reach the other equilibrium. So this is actually the situation for the nonlinear system, where the stability of the this is first of all the notion of stability of equilibrium points that you have understood. In case of LTI system, we talk about stability of a system as a whole. But now, in case of nonlinear system, we have to talk about stability of equilibrium points, because one system may have multiple equilibrium points, and then you have to analyze the stability of each and individual equilibrium points, right? And another important fact, that the stability of the nonlinear system, the stability of this equilibrium points, they highly depends on the region of attraction, that means region of the initial condition. How it is relevant, I already mentioned. If you increase the theta dot, that means suppose your perturbation is so high that the pendulum, it attains the plus pi comma 0, that location. That means that is here the zone of the initial condition is much beyond this circle. So then if it is in the vicinity of another equilibrium point, then of course it will try to attain that equilibrium point.
Now sir, if all those points were stable,